Hello students, welcome back to my channel. In this video, we're going to discuss one more example based on Fourier transform. Okay. In the last video also we have discussed Fourier transform of a function. Okay. So this is a similar kind of example which we have already solved in the last video. Okay. So here we are going to use both Fourier transform as well as inverse Fourier transform here. Okay. Okay, let's go step by step. Okay, first you can write the Fourier transform of f of x, which is already integral runs from minus infinity to infinity. F of x into e raised to iux into dx. And as I told you already, okay, what does modulus of x less than or equal to 1 meaning I explained in the last video, which means minus 1 less than or equal to x less than or equal to 1. I told you already how to use the value of f of x inside this range, that is minus infinity to infinity. So draw a number line. Okay, middle value is 0, left side is minus 1, right side is 1. I told you already, only in this interval minus 1 to 1, the value of f of x is 1 minus modulus of x. So otherwise means in this interval and in this interval, its value is 0. That is f of x value is 0. Here it is 1 minus modulus of x. Here it is 0. Or in other words, you can also write f of x value is 1 minus modulus of x in the interval minus 1 to 1. 0 otherwise. Fine. Now let us use this. And I explained we are going to use one of the property of a definite integral, which I used in the last video. Just go back and see the video. I will give the description of that video. I will give the link of the video in the description. Please go through the video. Okay, now which is equal to integral runs from minus infinity to minus 1, minus 1 to 1, next 1 to infinity. Okay, let us write as it is f of x into e raised to iux into dx, f of x into e raised to iux into dx, x into e raised to iux into dx. So use the value minus infinity to infinity, minus infinity to minus 1. The value of f of x is 0 into e raised to iux into dx, plus intervals from minus 1 to 1, f of x value is 1 minus modulus of x into e raised to iux into dx, plus integral runs from 1 to infinity. The value of f of x is again 0 into e raised to iux into dx. So first and last values are 0. Okay, integration of 0 is 0. Okay, so here, so what is the value of modulus of x we are going to consider is a big question here. So to achieve this, so we are going to make use of the definition of modulus of x. Modulus of x value is positive when x is greater than 0. Its value is minus x when x is less than 0. Okay. So for that, I am going to split minus 1 to 1 as, again, this is minus 1 to 0 and 0 to 1. So minus 1 to 0 means negative, then modulus of x becomes minus x. So this will become 1 plus x into e raised to iux into dx. Here 1 minus modulus of x value is x itself into e raised to iux into dx. So now let us integrate this. Integration of 1 plus x into e raised to iux. We are using the Bernoulli's rule. Okay. First function 1 plus x. Integration of e raised to iux is e raised to iux divided by iu minus differentiation of 1 plus x is 1. Again integration of this total is e raised to iux divided by, there is one more iu is multiplied, it will become whole square between the limit 0 to minus 1 1 to 0. So why I have stopped here? Because the differentiation of 1 is 0. Plus similarly this is first function 1 minus x e raised to iux divided by iu minus differentiation of 1 minus x is minus 1 into e raised to iux divided by iu whole square. Okay, fine. So further, we can substitute upper limit and lower limit. Okay, by substitution of upper limit and lower limit, try to understand this. Okay. I am going to copy this. Okay, I have copied that and I will paste here. Fine. Okay, so this is uh, f of x value. This is not f of x, Fourier transform. That is f of u. So this is minus 1 to 0 and this is 0 to 1. Fine. Now substitute upper limit minus lower limit here and observe what will happen, which is equal to here. The first term will take 1 by iu outside. Upper limit is 0. This is 1 plus 0 into e raised to 0 is 1 minus e raised to 0 is 1 divided by, this is I square u square. So upper limit 0 is over minus lower limit minus 1. The substitute x equal to minus 1, the first value becomes 0 minus substitute x equal to minus 1 will become e raised to minus iu divided by, this is I square u square. So upper limit is over minus, sorry, upper limit minus lower limit is over. For the second term, substitute 1, first value becomes 0, is minus minus plus, substitute 1 e raised to iu divided by I square u square minus lower limit, substitution of lower limit, 1 minus 0 is just 1 into 1 divided by iu, because e raised to 0 is 1, plus e raised to 0 is 1 divided by I square u square. Now this is 1 by iu minus 1 by I square is minus 1, minus 1 into u square, minus minus plus e raised to minus iu divided by, this is minus 1 into u square, plus e raised to iu divided by minus 1 into u square minus 1 by iu minus 1 by I square value is minus 1 into u square. So look at students, plus 1 by iu minus 1 by iu get cancelled. So here you can observe both are minus minus plus, here minus minus plus, 1 by u square plus 1 by u square is, which is 2 by u square. Again both are negative here, negative negative. So it will become, that is 1 by u square is common, you will get e raised to iu, okay, plus e raised to minus iu. Fine. Now as usual we have to use the values. E raised to I theta is equal to cos theta plus I sin theta. If there is a minus, there is a minus here. Right. So which is equal to 2 by u square minus 1 by u square times of, you can just use it, e raised to iu is cos u plus I sin u minus cos u minus minus plus I sin u. So cos u get cancelled, sorry, cos u minus cos u plus cos u get cancelled. I sin u plus I sin u is, which is 2 by u square minus 1 by u square into 2I sin u. You can take 1 by u square outside or 2 by u square outside, you will get sorry, just since it is positive, so this is minus sign. So here plus I sin u minus I sin u get cancelled. Okay, so this is cos u plus cos u is 2 cos u. So this is 1 minus cos u. So 1 minus cos u is 2 by u square into 2 sin square u by 2, or this is 4 by u square into sin square u by 2, is the Fourier transform of given function f of x, which is denoted by f of u. Now let me go for finding the value of, just look at finding the value of integral runs from 0 to infinity sin square t by t dt value is equal to pi by 2. You need to show here. Okay, for that we are using, as you know already, we are going to use the inverse Fourier transform definition, that is f inverse of f of u is equal to 1 by 2 pi times of integral runs from minus infinity to infinity f of x into e raised to minus iux into du, which is same as f of x. So I will write in the reverse order. F of x is equal to 1 by 2 pi times of runs from minus infinity to infinity. So what is this is f of u, f of u. So what is f of u value, which we have already got, which is 4 times of sin square u by 2 divided by u square into e raised to minus iu x into du. So as you know already, we need to substitute again x equal to 0. So f of 0 is equal to 1 by 2 pi times of integral runs from minus infinity to infinity. You can take 4 outside. This is sin square u by 2 divided by u square. So e raised to 0 is just 1 into du. So f of 0 value is, okay, f of 0 value is, just go back and observe. If I substitute x equal to 0, if I substitute x equal to 0 here, or if I take x equal to 0, x equal to 0 lies in the first one. Its value is 1 minus modulus of x. Again, x equal to 0, you will get just 1 only. So directly go back and take f of 0 is 1 is equal to, this is 2 by pi minus infinity to infinity sin square u by 2 divided by u square into du. Cross multiply it, we'll get pi by 2 into, I told you already that sine function is odd, sin x is odd, but sine square x is 1, and denominator u square is also even function. So in such a cases, you people already aware that we can able to write it as integral runs from 0 to infinity. Half of this, and this is sin square u by 2 divided by u square into d. Okay. So here, student, we can divided by 4 and multiply by 4. So why I am doing in this manner? Because I am going to substitute here. What I am going to substitute here? I'm going to substitute it as, just get carefully. Okay. Substitute u by 2 is equal to some t. U by 2 is equal to t. Then u becomes 2t, and differentiating you will get du is equal to 2 dt. And the limits also varies from, since we have u lies between 0 to infinity, changes to t lies between 0 to infinity. Therefore, left side is pi by 2, keep it as it is. This is 2 by 4, keep it as it is. Okay. So interval runs from new values runs from 0 to infinity. This will become sine square t, and du is equal to 2 dt divided by u by 2 whole square. Okay, that is u by 2 is taken as t square. Okay. So 2 2s are 4, denominator 4 get cancels. Therefore, I will write in the reverse order. Interval runs from 0 to infinity. Sine square t by t square into dt value is 5. Thank you so much for watching. If you find any difficulties in this video, please mention your comment in the comment section. Thank you so much.